Hello and welcome to this webcast titled SOA or SOA, Federation Across the Extended Enterprise and the Cloud, brought to you by Layer 7 and InfoWorld. On behalf of InfoWorld, I'll be your host today, Vanessa Boris. SOA is key to business agility, and with so much to offer in the way of cost savings and enhanced business practices, it has been widely embraced. But what happens when you extend SOA across the enterprise, the extended enterprise, and into the cloud? The security issues are multifaceted. Private and public clouds introduce further challenges owing to their multi-tenancy and shared infrastructure. How do you deal with different identity definitions? How do you leverage existing access and single sign-on infrastructure? How do you consistently define and enforce access policies across heterogeneous environments and the cloud? Well, we're going to dive right into these important questions and much more to help you understand what makes sense for your organization. Joining us for what we know will be a very fascinating discussion are Randy Hefner. Randy is Vice President and Principal Analyst with Forrester Research. And for those of you who don't know Randy's research, aren't familiar with it yet, he focuses on enterprise architecture and is a leading expert on architectures and design approaches for building enterprise applications that are secure and resilient in the face of continuous business and technology change. And this makes service-oriented architecture, or SOA as we know, one of Randy's primary focus areas. Randy, in fact, led the development of Forrester's digital business architecture, which provides a broad architectural context around SOA. And joining us as well is Scott Morrison, who is the Chief Technology Officer and Chief Architect at Layer 7 Technologies, where he is leading a team to develop the next generation of security infrastructure for cloud computing and SOA. An architect and developer of highly scalable enterprise systems for over 20 years, Scott has extensive experience across industry sectors as diverse as health, travel, transportation, and financial services. So stay tuned to learn much more about SOA Federation across the extended enterprise and into the cloud. And just a couple quick notes before we get started. In order to take advantage of the interactive features of the webcast, including our audience polls, please make sure to disable any pop-up blockers you have. All the slides will advance automatically for you through the webcast, and we welcome your questions. Please send us your questions at any time during the webcast. All you have to do is type them into the box and hit the Submit Question button. So, with that housekeeping out of the way, we would like to begin our presentation. And first to speak with us is Randy Hefner. Randy?
Thanks, Vanessa. So we're talking today about a particularly advanced usage of SOA for securing and using it in an extended enterprise that exists in multiple locations across the Internet. And so let's start with just a general picture of the status of SOA in the industry, in case there's anyone out there kind of wondering, well, should we be talking about this SOA discussion anyway? You know, what's the status? Well, if you look at the data, Forrester survey data shows that SOA is strongly entrenched. It's mainstream in the industry. You look at the largest organizations, and 84% say they'll be using SOA by the end of this year, 74% already using it. And the majority of those large enterprises have an enterprise-level commitment to SOA. And even down to the smallest organizations, we have about 40% that say they'll be using SOA by the end of this year. So SOA is firmly established in the industry as a best practice and is an important piece of any modern application architecture. But you may say, well, maybe many are using SOA, but aren't there all these problems with it, and people are having lots of trouble? Well, there are some struggles, but here's an important bit of data. Across all sizes of organizations, the majority say that they are getting enough value from SOA that they are going to expand their use of SOA. And only about 1% say that they've tried SOA and haven't found the benefit, and so they're turning away from SOA. For some, it's too early to tell, But there is this group in the middle of 15 to 20% that say they struggle for benefits, and they're not really going to expand SOA until they solve some of those issues. So there's some struggles. SOA is not an easy thing to do, particularly when you start talking about an advanced scenario like an extended enterprise. Well, good governance for SOA does a lot to help, and some other surveys that we have show that the number struggling to get benefits with SOA might even go very near zero when you get good governance in place. And part of good governance is getting good design patterns so that you can get it right up front, so that you can continually learn and govern toward a quality implementation of your SOA solutions and the infrastructure underneath those solutions. So let's take a look here at an area that needs governance. How do you do these advanced scenarios for an extended enterprise? And what are some of the more complex security requirements and security design parameters that come up? But a baseline to start with first is to understand that simple SOA security is simple. If you got one security environment inside your environment, your world, whether this is your service and a business partner or whether it's all inside your one environment, if you approach it as a single security environment and have a consumer and service platform and just set up a two-way SSL or other simple VPN connection between them, you've got secure SOA. It's simple. It's a simple solution. This is the way that a lot of SOA security is done, and even external integration. But the point is, it's simple. We see 65% of users in one of our surveys said that this kind of solution is an important or mandatory part of their environment, but they also said that they needed more because this is simple and an extended enterprise is not so simple. You start off by just realizing, well, you've got this one core environment where you may have services, you may have service consumers, and then you've got business partners. They have their own security environments. Some of your business units may, in effect, operate as independent units and are much like a business partner. And then we've got this new wild card that's been thrown into the picture, cloud provider environments that might be owned by a business partner, a business unit, might be owned by you, but they're separate infrastructures, and again, with their own, potentially their own security environments that's separate and distinct from yours. So environmentally, an extended enterprise scenario starts out not being so simple, and so we start having to think about more requirements, more than just what a simple SOA security solution might provide. But it's not just the environment that's more complicated. Business requirements are getting more complicated as well at the same time. Whether or not you're in a cloud extended environment, business requirements in general are getting more complicated, and that adds to some of the additional complexity in an extended environment. That business needs greater accountability, that we need to understand who's doing what in our applications, and this pushes us very often to where we need to know not just the application or who the business partner was, but who the actual end user was that was causing something to happen. But it might be 3 service calls later that were actually is the function that we most need to have this deeper accountability for. And so we need some stronger security architecture than just a simple VPN. We need richer entitlements to get much more deep and nuanced in the restrictions and the rules about who can see what. And a simple VPN solution that basically uses a pattern, authorization pattern we'll talk about in a little bit, that is implied authorization is the general usage of simple VPN. If you get access to the service, you can use it. That's implied authorization. But we need richer kinds of entitlements for authorization. Push up the number of business partners, and a simple VPN solution and the certificates that you have to manage for that become much more of a burden. And not to mention just the burden of managing multiple partner relationships. So that gets more complex. And in the midst of all this, we need greater flexibility. Different partners have different requirements. We may be changing those policies as we evolve our business and optimize our business. So these requirements add additional complexity, more design parameters to how we get SOA security. As we go forward, we want to do a little bit of data on that, and I've got some data for you on drivers of SOA security. But Vanessa's got a poll here for us that we can look at and see what your particular requirements for the audience here today are.
That's great. I think it would be really fun to see what folks think should be the drivers in their own situation. So here's the poll, and we are asking you to check all that apply just by clicking on the blue box there and the radio button on your side. Which of the following are drivers of your most stringent SOA security requirements? And these would be either business requirements of our applications, and that's your applications, internal corporate security mandates, and these are not due to regulation, Sarbanes-Oxley or similar regulations, privacy regulations, or perhaps you're under other government regulations. So please choose all that really apply to your situation. And Randy, you've talked a lot with folks recently. What are your observations about the nature of drivers for security?
I'd say there are three biggest kinds of things that are happening to drive deeper requirements for security. There's a trend toward more and more sensitive data being available in Internet-based, interconnected solutions. You think about, for example, my airline or my bank. I log into their website. The number of functions that I have and the things I'm able to do now are dramatically more than what I might have done just 5 years ago. They keep adding more functions, pushing more self-service capabilities. That means more sensitive data, more sensitive transactions, and that pushes deeper security requirements. We're also doing, the second one would be that the way we're building these solutions mean that we're doing more and more deeply interconnected apps. Things are getting deeper and deeper, more deeply integrated. We're bringing more piece parts to the puzzle from different package, might be a package solution, a cloud environment, a business partner, multiple legacy applications, and so the security picture in that environment gets more complex. You either have to make some very broad, simplifying assumptions, but we're back to simple versus complex, or you address the real complexity of the solutions and the deeply interconnected apps creates. And then third, there are multiple ways that we're pushing a need for deeper business accountability. Regulation does a lot of that, but also just business rules and business continuity and business processes push deeper business accountability as well. Well, so we got the data.
Yes, we do. Yeah, I thought.
Yep.
That was great. We got a great response from our audience, and it's kind of hard to tell because it's not one-for-one vote. Folks are able to choose multiples here, but we have very clear trends.
Yeah, well, and I think what's very interesting is that the same there's a consistency of a general trend here where it's not so much regulation, which really gets the big conversation in the industry about why things are changing. Well, we got all this regulation, but it's really internal things, internal corporate security, business requirements of the solutions that our audience today says drives their most stringent security requirements, and then regulation. And here we've got a little bit of a switch because Sarbanes-Oxley is the least in this in our audience's terms, but in a broader survey that Forrester had done, Sarbanes-Oxley was above the other two regulation categories in the survey, but our audience today has that same top-level requirements that are driven not by regulatory things, but by these internal business requirements factors that we talked about. So our audience today is very consistent with the general population. But what this means is, well, of course, you know how important it is to address regulation requirements. I used to work in the litigation support industry, and from time to time we'd get something related to some legal case that was we need this report in the morning or the client is going to jail. Well, these regulatory requirements, that really can happen. People can go to jail, so those are important. But if those are important and our internal requirements are even more important, then I think that emphasizes how important it is to address these more complex requirements. So let's turn to look at some of the major factors that you have to consider as you're designing your SOA security solution in an extended enterprise environment. And these requirements as well are that we'll talk through are really broad application security requirements, but they take on a little different flavor and different technical characteristics when we look in an extended enterprise. But the first one that we ought to look like is just the source of and design for identity. We're showing these 4 kinds of environments in an extended enterprise. Identity could be managed in any of these. You could have a login environment to any or all of these. And so you have to begin by understanding where and how do you manage identity across the environment. And the first key question is, well, who actually is the security principal? The one that we need to hold accountable? Is it just the application or service? We just need to know that this request came from the customer service application or some customer service in SOA terms. Maybe all we need to know contractually is that this request came from a business partner. We don't care who originated the request. We just count on the business partner legally to make sure that only authorized and authenticated requests get across. Or do we need to know the individual user, which could be one of our individual users or an individual user at a business partner or in a business unit or an individual customer coming through a cloud environment or whatever. So we need to understand who is the security principal, and then where is their identity maintained across these 4 environments. One place, well, that is simpler in a way, but may not be doable. We may have multiple identities. Their identity could even be maintained at a third party, like a Facebook or a Google or somebody like that. So we need to understand where the identity is maintained so that we know how to design our authentication processes. Next is we need to understand how we're going to integrate identity based on where the identities are. And here, what we first need to understand is if there's one identity per principal or whether there are multiple identities. If I have my Forrester ID and I have a Twitter ID and I have a something else, well, which one of those are going to be involved in our applications? And the answer might be one or more than one. Well, if there's one, then we need to know when we actually need to do an authentication, where are we going to go? We can synchronize IDs across these environments, or we can have real-time integration across the environment so that we go to the actual source in real time to get the identity and to verify credentials. Or if there's multiple identities, then we need to understand where we might come in and how we get to the other identity, whether it's via an identity mapping, so we keep credentials so that we can log in, behind the scenes log into another environment for someone, or whether they have true federation going with some of the federated identity technologies that are out there. So with these questions, we drive the core answers for how we're going to integrate identity. Next, we need to make sure that we're keeping effective access control, no matter which direction across this environment that access is going, whether it's from a service to a service in our environment, from a consumer elsewhere, or from a consumer in our environment to a service that's elsewhere. And here the first thing to understand is what actually is the enforcement point where we'll catch, require authentication, require authorization, and that could be across our environment. Each separate application platform, a Java application server, .NET server, legacy or a packaged application, Or we could use an intermediary-based architecture, and there are multiple different kinds of product categories from which to get an intermediary. But there are trade-offs here. You get deeper security going to the platform. You get more unified and controlled security going to the intermediary. And if you need both, then you have some additional integration that's required, so the intermediary can pass on credentials to the underlying platform. And then how flexible are the entitlements? I mentioned implicit authorization before. That's where if you're authenticated, we'll give you access to what's our environment. The older method is an access control list that's hard to maintain generally. Role-based security is a bit easier to maintain, but often will not meet the requirements of very fine-grained sorts of control. Like I can see a document only if I'm in a role and associated with a particular region or a particular client or a particular account. For that, we need policy or rule-based entitlements, and that is a very important part of how flexible your security environment will be, which then leads to the question of policy management. How do I edit, update, maintain the policies by which I'm managing security and controlling access in my environment? And here we need to understand how rich policy authoring is. In some environments, we may only get prepackaged policy, what the tool is capable of doing out of the box. Well, we might need content-based policy. I'm requesting access to an airline reservation. Well, am I the owner of that reservation? Is my name on that reservation? Do I know the record locator of that so that I can get access to it? But that we're basing things on the content of the request, and there can be various ways that we might need to plug in custom policy engines into the environment so that we can do even more complex things. And then we need to understand from an operational perspective, how robust is policy deployment? If we say a policy has changed, how sure are we that it actually gets out to every enforcement point? We could be manual. That's error-prone. But we need it to be scheduled and managed. Transactional is really what we need. So it gets to all the enforcement points, and we know that it does. But then even we need that policy enforcement points are able to operate independently without a connection back to a home base, so that when things go bump and network segments go down, that authentication and authorization, particularly authorization in this case, can continue to work. And then the final major requirement, a major design area that I'll point out, is auditing. As things happen across the environment, there are all sorts of different logs that are maintained, security logs, application logs, and at multiple layers of the environment and the application. But we need to understand, where are the relevant security logs? If there's a breach, if worst comes to worst and we find ourselves in a courtroom, what kind of security log, what kind of audit trail will we be able to construct? And what will be part of those audit logs? Can we show service requests and responses? Can we show how policies change so that we can prove what policy was in force at a given time? Can we show identity changes to prove that an identity was active at a given point in time? This can get very complex, but it requires a lot of thought to understand what kind of audit trail you can create. So there's 5 major areas of design considerations, and some of the key questions, just to give you a flavor of what's necessary to address these more complex requirements. And you can build this all yourself, but each product that will be part of your environment is going to have some capabilities that contribute to this mix, and you want to leverage those capabilities as much as you can. So let's wrap with some recommendations. And specifically, as you're working through these questions, the single most important question, the one that drives more answers to these design issues than anything else, is whom do you need to hold accountable and to what legal standard? As you drill into that question, does it just need to be, we just need to be able to have a conversation with them, or do we need to be able to prove something in a court of law? Then those drive answers to how detailed the security parameters and design and auditing need to be across the way. understand your extended enterprise potential as you work into this environment. Don't design to a particular version of an extended enterprise, but understand the potential. That means you need flexibility in the architecture. And what you're doing here for SOA shouldn't be standalone. It should be part of an overall vision for application security that includes SOA, BPM, legacy, that goes on to broader sets of application security concerns. So your SOA security environment should build on and integrate with other aspects of your application security vision. And then design the architecture around three major points. There's more, but these are three focal points that I think will help you answer some of the more detailed questions. Let those who are responsible do the administration. If the business partner is responsible to say who can have access to the system, then design a federated environment so they can do the administration of their users. Hold people accountable for what they do. That's tying back to the first question. And build it so that the architecture and environment can adapt to a variety of technology scenarios because things will keep changing, new standards will come along, new environments, new flavors of an extended enterprise that you hadn't even considered as yet. But if you do those things, it'll keep on track with strong SOA security design. Scott, let me turn it over to you.
Great, Randy. Thanks a lot. And that was a really, really interesting talk. And I think you really captured what are the fundamental architectural ideas that I think are behind this whole problem of identity, where identity resides, how identity travels and is transmitted throughout a network, and what are the key decision points, whether it's authentication or authorization that have to be made and how they're going to be made, and what do you have to keep track of in terms of audit. And that. So what I want to do is I want to take a cue really from the talk that you just did and then go right down into the weeds a little bit. And when I say going down into the weeds, I don't mean that I'm going to get too involved in particular instances of technology. But instead what I want to do is actually take some sort of real-world scenarios and look at the kind of real communications that takes place in a very, very simple use case-driven sort of model and look at how we can very specifically start to solve a number of these problems. So here's the first example. And like I say, I like to kind of distill it down into its essence in terms of actors and systems and things like that. And so let's think about SOA in a little more concrete sense, where we're actually looking at literally a service requester, a system or a person or what have you, that's actually trying to get access to some kind of service on a remote system. Now, in this case, let's say it's local. Okay, this is on our local area networks. We're behind a firewall and everything like that. So we're not going to worry too much about threats and things like that. But instead, we're going to consider a lot of the issues behind things like access control and what it means to communicate identity between these two systems. Because when you think about it, if that blue guy down there is requesting some kind of service, let's say it's the HR service, and that blue guy is making a request to find a very particular record, let's say the record of Scott Morrison, the CTO of Layer 7, find out where else he's worked in the past and if he has any disciplinary action taken against him in the past or something like that. The questions we have to ask are things like, how do we identify, that requester? And does he have the actual entitlements to actually get that kind of information? And when you start to boil it all down into a very, very simple use case scenario like this, what'll fall out of this? And I think what will really resonate with people are, what are those core questions that you need to ask about how you represent identity? And once you represent it, how you actually communicate it around. That blue guy down there in the lower left, who is he? Is he somebody who matters within the organization? How do you render who he is? In other words, what's the representation of that? Think about, how we in the real world, render our own identities all the time. We've got driver's licenses. We've got passports. We've got different forms of identification that bind sort of unique characteristics and naming conventions, to us as people. And the binding really is something as simple as a picture, which we can associate those credentials, those attributes and things like that, the name, the age, the where I live, with, the physical person that I am. But it turns out that it starts to get a little more complicated as you get into more advanced SOA. Because that person, that blue guy there, might not actually be a human being, might actually be an application, might actually be a computer program. And what does it mean then for a computer program to have identity? And if it's got some kind of identity, how do we render that? Like, how do we make sure that that computer program actually can essentially, exchange some kind of evidence that it is the computer program that it thinks it is? So these are kind of the fundamental questions that I kind of want to go through with very simple scenarios like this and start to talk about in detail. And of course, the last piece that Randy talked about that I think is equally as important is the whole idea of audit. How do you actually start to render some kind of information there, on your service provider, so that you know exactly who it is that's actually made these kinds of claims. So if that blue guy is Scott Morrison and he's trying to get access to the HR service, you need to have some kind of forensic information that actually talks about that. So let's talk about this in a little more detail now and talk about how we could possibly solve it. And it turns out, again, if we distill this down into its very, very basic essence, it's actually pretty easy to do. And in fact, this is that scenario that Randy was talking about earlier where, 65% of the people really think this is important, this sort of quick one-off that, allows you to solve this problem just using the technology that's out there today. If you look at, let's say, a simple web services scenario like I described, you could use things like, an LDAP directory to actually hold the identity claims. You could use things like HTTP basic credentials to actually render some kind of evidence that the blue guy is who he says he is. And, of course, audit can go to syslog and things like that. These are all kind of fundamental elements that architecturally we're all very used to. And our infrastructure, whether it's a web services container or, let's say a SOAP client or what have you, all of these kinds of things are actually, out there, very common, and we're used to using them. So building this as a one-off actually isn't very hard. And in fact, a lot of the people on this phone or this webinar have probably done just that. I've certainly done it a lot myself. You can set this up. You can get up and running in no time at all. That's not a problem. This is where the problem arises. The minute you start to get into a complex scenario where you have a lot of different parties, a lot of different architectures, a lot of different systems, then it gets more complicated. It gets very complicated to actually do it consistently with all the different systems. So think about this. What if that service provider in one case is a .NET server? In another case, it's a Java server. In the other scenario, it's a Ruby on Rails system. All of these have that basic capability, but the problem is all of them do it a little differently. And certainly the administrative burden of trying to keep all of those different systems consistent starts to get very, very significant as you begin to scale up. And this is the real fundamental problem that you start to run into here in any kind of distributed computing model where you have a lot of different systems. You get this issue of having to, take on an enormous burden in terms of how you administer all of this, how you manage it on a day-to-day basis. So here's the answer that we at Layer 7 have come up with over the last 7 years to deal with this. And this is a model where you actually separate out policy enforcement, not, and don't try to integrate it into the actual service hosts themselves, but literally separate it out into a completely separate unit, a policy enforcement point, literally a new kind of technology that sits in between a sender and receiver of information and applies things like access control policies to that stream of communications back and forth. So in other words, this is the border guard. This is the system that sits there and actually makes sure that only the right people can actually get to the right services at the right times. And not only that, it's all governed under a very, very strict and rigorous policy system, which takes care of things like auditing, which simplifies your management because it's all in one central location. Now, this isn't a particularly new idea when you think about it. I mean, this is really a classic proxy model, but it's a very, very smart proxy. It's a proxy that knows a lot about all of the different kinds of protocols that have become the basis of SOA. Now, I mean, when you think about it, SOA is sort of this architectural practice. It's not a technology. It's an approach to actually building systems, an approach to integrating systems together. But in reality, as all of us know, when the rubber hits the road, you actually get down there and you have to start thinking about protocols, and you have to think about real technologies and that. And this is where things like the Secure Span Gateway system is actually very, very valuable, because it's a real realization of one of these policy enforcement points. It can handle all of these different components, and it can do it in a very, very consistent manner. It's not an agent-based system. So I mentioned earlier, it doesn't attempt to plug into all of those different application servers or anything like that, because in reality, that just doesn't work. Again, think of the diversity problem at the very beginning, where you've got .NET, you've got Java, you've got Ruby on Rails, you've got Perl systems, you've got mainframes that are actually starting to produce services. How can it possibly be realistic to have the same kind of enforcement code running in all of those different environments? I'll tell you what happens is you actually end up building something that is so sort of simple and detuned, you fall to the lowest common denominator very fast, and really you take a race to the bottom. If you tease that out, if you pull that out and say, I'm going to instead put a central common policy enforcement layer in the middle, and that's going to be my key point of enforcement, all of a sudden you get consistency across all of those. Because think about it, what is your interface point between all of those different systems, the Ruby system, the Java system, the .NET system? It's basically network protocols. It's basically things like TCP, it's HTTP, it's higher level protocols like SOAP or REST-style interfaces and things like that. And quite frankly, these are actually very well worked out. These are well rendered, articulated, and standardized. So it's the kind of thing that, as a point of interface between these systems, makes a tremendous amount of sense, much more than trying to, plug into, mod an Apache mod or a Java servlet engine or something like that. So teasing the policy enforcement point out is a very, very strong design pattern for this kind of model. Now, when you do this, of course, and you use something like the Secure Span Gateways from Layer 7, you're also interested in actually leveraging existing investment, which, of course, in the case of a lot of organizations, is identity and access management investment. It's things like the LDAPs that you've got, or the, let's say, the IAM system, the Tivoli or the ClearTrust, or the Oracle Access Manager, or the Sun Java System Access Manager, or whatever. All of these different investments have to be brought in to the web services world, the REST world, the SOA world. And that's where things like Layer 7 can actually really help you out. They do the heavy lifting of understanding those protocols and doing the enforcement, but also integrating with every one of these different systems. And we've spent a lot of time actually building plugins so that we can talk to every one of these systems. We can talk all of the different identity tokens. We can talk all of the different identity backends and mix and match those together through the context of policy. And policy, for us, is a very important thing. It's the language that articulates access control rules, connectivity, load balancing, SLA, orchestration. All of these elements can be wound up into this concept of policy. It's the language that allows you to manage this. And that's why we call these things policy enforcement points. They're there to actually enforce the rules, enforce them through that language, that policy language that you can put together. So a lot of you are probably thinking, well, what you've just done here is created a bottleneck. I mean, by taking things out of the application servers and putting them into a centralized policy enforcement layer, what you've just done is create a single point of failure, a place where all of your traffic's going through, that and so the systems can't possibly keep up with that. Well, it turns out that that's actually something we thought of, and we spent a lot of time dealing with this problem. Because, of course, you never want to just put one of these in there, because in that case you really do have a bottleneck or a potential, single point of failure. So instead what Layer 7 did is they thought a lot about the whole problem of clustering, so that you can put in multiple instances of these devices and actually get higher throughput, higher scalability, but also a tremendous amount of fault tolerance. So you don't have any bottlenecks. You don't have any key single point of failure that is actually going to be a problem anywhere. And we spent a lot of time thinking about how we synchronize policy between every one of these systems. So as an administrator, it becomes trivially easy to make changes and have them automatically propagate between all of those systems. Things like replay attacks and that, where you need coordination between all of these different policy elements, that gets done too. It's automatic. And it's actually unique to the industry. It's something that Layer 7 does that nobody else does out there. And it's actually a critical part of building an effective security model that works for you in the SOA world. So that's the really simple problem, okay? So I zoomed in and said, okay, here's a very simple use case that we all come up against all the time, where literally it's just two systems, within a normal network or something like that talking to each other. And we can interpose that policy enforcement layer and start to get that scalability, start to deal with all of the different systems, as they begin to propagate in our networks that we've actually really got in the real world. But what happens as we start to move out, and this is the key point that Randy was making earlier, is you get a tremendous amount of complexity, not just as you get different systems in your own environment, but even more so as you start to actually move out into different identity domains, such as working with, let's say, a branch office, or in, this current economic climate where a lot of companies are, doing M&A and taking over other companies. As you integrate in other companies that have existing identity and access management systems, how do you begin to unite these into a cohesive whole that can reasonably be called, well, one company? How do you go from the green environment to the blue environment? In this example right here, where you may have similar representations of the same people. For instance, if you look down here, I might, Scott might exist in two places. I might exist in that green domain. I might also exist in the blue domain. How do I tie that stuff together? How do I start to cross those boundaries? And this is federation. And this is the problem of federated identity that we fundamentally have to deal with. And with that, what I want to do is actually get Vanessa to ask some questions in a poll, because I think it might be very enlightening for us to get a sense of where people are seeing federation problems out there in the real world. So Vanessa, take it away.
Thanks, Scott. Yes, we really would like to hear from you in our audience about what technologies you feel that you need to federate. Now, like the past poll, we are welcoming you to choose multiple answers here, and maybe more apply than just web-based, browser-based communications, the SOAP web services, RESTful web services. Perhaps there's something else that you need to federate that we haven't listed. And we also left an option, I don't need to federate anything, although, Scott, I think we're not expecting many people to choose the final response, I don't need to federate anything.
It's true, actually. I think, these days, if you'd asked this question maybe 5 years ago or something like that, I think you'd get a lot of that last one. But I think these days we're seeing less and less of that because, everybody has the problem of single sign-on. And federation is really, when you think about it, single sign-on taken to the multiple identity domain world. So in other words, it's the recognition that I've got a Facebook ID, I've got an eBay ID, I've got an ID out on Salesforce.com, and I've got the Scott Morrison ID here at Layer 7, in our own Active Directory system. How do I get unity between those? How do I solve that problem? And it's really a problem that all of us have. So now it's more a case of understanding, where it's coming up, where this is, where the real first pain point is that's hitting everybody. And also a recognition that as we get more advanced in our understanding of this problem, it starts to hit other kinds of technology. And that's the essence of what we're trying to get to with this question.
Okay. Well, let's see what folks have to say about this. The results are pretty clear. We have a SOAP web services is our number one selection from this audience with about 50%, followed by web browser-based communications. Not really a surprise.
No, actually, not really. Just to use the example or extend the example that I used a minute ago, something as simple as going out to Salesforce.com. I mean, it's a great SaaS application. We use it here at Layer 7, frankly. But how do I federate that? That's a browser-based SaaS application. So it's a very real problem. But what I'm really interested in is how many people are genuinely up against that problem of SOAP web services. Because fundamentally, that's what we do really well here at Layer 7. we as a company have focused, very, very in a lot of detail over the last 7 years, really, in solving the very difficult problems in web services, and in particular with things like SOAP. And when you think about it, that's really the origin of the name Layer 7. It's sort of a nod back to the old OSI model from the 80s, where we were thinking about application layer protocols. Things like SOAP add a lot of complexity to that application layer, and you have to have intimate knowledge of the protocols in that quite frankly, are changing all the time at that application layer. And you need to think very, very hard about how you can leverage those protocols to actually deal with things like authentication, authorization, and so on. And it is very complex. It's a lot more complex than browser-based federation. And it turns out that you really need to apply some very, very specialized technology for it. So with that, why don't I show you some of that technology exactly?
Great.
Here it is. What we've done for federation is, again, put the capabilities for doing web services-based federation for things like SOAP messaging, generic XML messaging, REST messaging, and even a surprising amount of just plain vanilla browser federation, and put that capability into those secure span gateways. So in a case like this that I was showing you earlier, where we had two different identity domains, the green domain and the blue domain, and if you'll look down there, I've kind of focused in on myself there. Scott exists in two different places now. How do I tie those two Scotts together and make sure that they're the same person? And where can I affect that change, on a transaction-by-transaction basis? Well, it turns out that we can do that within Secure Span right here. We actually have the capability of doing these kinds of identity mappings on the fly on every transaction, making use of local identity servers and IAM technologies using the existing plugins that we've got. So we can adopt a number of different identity mapping models, everything from a sort of a fan-in where everybody is consolidated into a local service account to a direct one-to-one mapping between different identities. And this is what we find is a very common stepping stone into true federation. I think this is, in a lot of ways, sort of a half step, really, into federation, because it's not leveraging some of the more interesting and exotic technologies that we'll talk about shortly in doing true, distributed federation. But I think it's a very valid and practical and indeed pragmatic step for dealing with these kinds of problems. So let's actually move on to, I think, the next, logical evolution of these kinds of SOA use cases, which is to move out into the cloud. And, when I look at the cloud, I get quite excited about it. I think it's a really interesting new technology. I think it is, fundamentally unique. I think like all good and logical technological evolutions, it builds very much on things that we already know. I think it harkens back to everything from, time sharing to, best practices for building web apps to, good ideas about scalability and how to scale databases and things like that on an absolutely massive scale. It sort of distills a whole bunch of things together and creates this highly elastic, highly scalable model that you can just pay for use on. So you've literally done that wonderful transformation from budgets that's dominated by CapEx expenditures to OpEx dominated budgets, which, quite frankly, is a very, very attractive thing these days. So cloud is something that's interesting a lot of people right now. And a lot of people have come to us at Layer 7 and said, how can you help me out here? Because the number one thing I'm worried about in the cloud is I'm moving applications out there or making use of existing applications that are out there in the cloud. How do I deal with security? I mean, I'm moving outside of my comfort zone. I no longer have these high castle walls around myself that I always had on my on-premise network. All of a sudden, I'm going out there into what's fundamentally a very hostile environment. You're crossing the internet. You're going out into a multi-tenant environment where the tenant right next to you might be a really loud, noisy neighbor that you don't want to have. They might be your competitor. They might be somebody who actually wants to harm you and your business. How do you deal with that? How can you gain that level of trust out into the cloud? And moreover, how can you start to move your identities out into the cloud? Because the last thing we want to do is to start to create yet another silo of identity out there. We don't want to create Scott Morrison identities out in the cloud that are related to, but fundamentally, disconnected from the Scott Morrison identity that resides, back in our Active Directory right here. How do we solve this problem into the cloud? Well, to that, what we say is use secure span again. Use secure span, but in a different pattern. So one of the things that we've done in Layer 7 over the last 7 years or so is we've built basically SOA technology for policy enforcement points, is we specialized in extremely high performance, hardware gateways that you can plug into your DMZ. They're hardened for security. They really offer tremendous performance in terms of throughput, in terms of transactions per second and such. They truly work at wire speed. You cannot push enough data through these things to really, peg the CPU in most cases, unless you're doing some extremely complicated policy processing. So they are extremely tuned. But, of course, a hardware gateway isn't something you can just go out and put in Amazon or put in Rackspace or something like that, or put out in GoGrid. So what we did is we took exactly the same fundamental code base that makes up the Layer 7 secure span gateways and made those virtualized and actually built them into, an entire virtualized policy enforcement point that you can move out into the cloud. And you know what? It's exactly the same from a functionality perspective as those, hardware gateways. It may just not be quite as performant, of course, because when you think about it, it's running through a virtualization layer. But it's still hardened. It's still running on an optimized OS, and it's still very, very easy to manage. So you can start to take these virtual devices, put them out into the cloud, and protect the services residing out there in the cloud. And in fact, using pairs of these devices, pairing them up, you can actually create secure tunnels, sort of like a VPN in a way, between your on-premise environment and your cloud environment. And I say sort of like a way with a VPN because Randy hit on a really important point earlier on, and I'll call you back to it, which is that idea of VPNs have a very loose approach to authorization. Really, they're just sort of kind of authorizing. I quickly, just trying to remember the term, I think it was implied authorization of a VPN. Because if you gain access to the VPN, you can really get access to anything the VPN can touch, which is pretty much everything there. That's why VPNs aren't great in the cloud, because clouds have a trust imbalance between that environment out in the cloud and your on-premise environment. In other words, if something breaks in the cloud, let's say for some reason there's a compromise, and it's a multi-tenant environment, so there's a much higher probability, or let's say maybe not probability. I should be saying there's a much higher risk profile out there of having a system cracked out in the cloud than having a system cracked in your existing on-premise network where you've got very good security, physical security practices around it and that you control. So in other words, the standards that you control in your on-premise network may not be exactly the same as your cloud provider. In truth, your cloud provider may have better practices than you. But the fact is, you don't know that. It's not under your control. You're ceding control to that other provider. And that creates an imbalance, a fundamental trust imbalance. And in those cases, VPNs just do not work. Because anytime you've got one of those imbalances, it means that you've kind of got a fundamental disconnect between the security models. And the last thing you want in that case then is just a wide open tunnel between those systems. What we do instead with Secure Span is we create that VPN-like connection, but completely under control of policy. So it's subordinate to authentication. It's subordinate to authorization and entitlements checking. And all of that is bound to a single transaction. So literally you control on a transaction-by-transaction basis the characteristics of that tunnel. And so that very, very fine-grained control between applications reduces your risk profile tremendously over trying to just put a simple kind of naive VPN between those two systems. And that is a fundamental difference that's very, very important out there. But let's talk more about the whole problem of identity, because if I'm saying that really what you want is fine-grained entitlements and identity in the cloud, how am I going to get that? Here's the first problem that you face. You don't want to just move identity validation out into the cloud, because the last thing you want to do is start putting key material out there. You don't want a directory server out there in the cloud, because the directory server is also going to have things like key material. Yeah, sure, the passwords might be hashed and things like that, but they're still subject to potential seizure, potential cracking, and fundamentally they could be subject to brute force attacks. And quite frankly, the cloud is a great place to launch brute force attacks. So you don't want to be putting classic LDAPs and IAM systems out into the cloud. Just not a very good idea. The other big problem you've got then is that you can't just go calling back to home again and trying to get access back into the home base again. That just doesn't work either, because when you think about it, there is no realistic path all the way back, into your home base LDAP directory or IAM directory. Nobody makes those available to the outside world. And even if you did, think about what happens if your cloud provider's on the other side of the continent. You get all the way out there, you come back, you go back out, with the response again. You're talking 30 milliseconds or something with fiber delays and that across the continent. All of a sudden, a single transaction is becoming ridiculously slow in terms of the overhead of back and forth across the internet. You just can't do that. It's not practical. So instead, what you need to do is think about this whole problem of using security tokens appropriate for the cloud. And we have technologies like that. We have things like Kerberos and SAML. But they're complicated. And especially as you get into the SOAP world, especially as you get into the XML messaging world, where there are good standards for this kind of thing, but they are, very, very complex to use and complex to enforce. Well, it turns out that within SecureSpan, within both the cloud gateways and also the hardware gateways, we're actually really good at that. And so we can help you set up basically a distributed enforcement model, which allows you to not tie yourself to concrete identities like Scott Morrison, because you never know. Scott Morrison might get fired tomorrow. Instead, what you can do is start to tie it to roles and attributes, like CTO, like the guy that resides in cube number 123 on the 4th floor in room number 9. Those kinds of things that don't change a lot. They're not tied to an individual person. Instead, they allow you to make authorization decisions by coalescing a lot of attributes and characteristics of the identity, the transaction, the entitlements that the resource you're trying to get access to, and all of those different entitlements. And that's the kind of model that you need to move out and employ as you move out into the cloud, because in places like that, it becomes absolutely essential. Now, finally, the other key point that I want to pick up on that Randy talked about earlier is this whole problem of policy migration and how you move policies around. Because the thing about policy is it gets polluted very quickly with localized information, things like URLs, things like local identity representations. You need a deterministic way of mapping those through the whole life cycle of your applications and the life cycle of your management and governance structure. Well, it turns out that's something we can do very well as well. We can actually map policies literally, from a drag and drop perspective in a very deterministic manner. So you do it the same way every time. And you know what? That consistency is the soul of good security. It's the soul of good governance. These are the kinds of tools that actually allow you to have a realistic, governance strategy. So with that, let me do a very, very quick summary. Cloud, for me, is really a deployment pattern for SOA. It doesn't replace SOA. We should be looking to SOA for what worked well with SOA, because we learned a lot over the last 10 years or so as we've been developing these things. Cloud is the logical place to actually deploy SOA, to use SOA best practices, and in fact, to use SOA technologies like SecureSpan and allow you to leverage the models that SOA has taught us. So we should be looking at the best practices like avoiding key material in the cloud, using distributed token validation to do true federation using things like SAML and that, and moving this kind of thing into the cloud, but also out into your extended enterprise. Because the truth be told, you can take what we've got out in the cloud and move it into your distributed environment, and it works just as well. So with that, I want to thank everybody for coming and sitting through this webinar. I think we've got time for a very quick question or two. Vanessa, do you have any question in particular that you'd like? I've got a list of them that have been coming up here as well.
Yes, I think we'll jump in just at the top of the list. And first of all, we have a question from someone who'd like to know, how do you reconcile multiple attributes or compute effective policies, in quotes, given several policies? Which is a really interesting question, I think.
Oh, that's a tough one. And when I say tough, not necessarily tough to answer how to do it as much as how to solve that problem. And in fact, we spent a lot of time at Layer 7 looking at exactly that, is how you resolve an effective policy from, let's say, all of the different attributes and characteristics of the policy that may not necessarily be appropriate for everybody's consumption. Here's an excellent example. Within a policy on a Layer 7 gateway, you might have information about internal routing and internal addresses and that. Obviously, that's not something that you publish to the outside world. Similarly, even your entitlements and that. not something you want to tell to the outside world, but it's an integral part of policy nonetheless. So we've actually got some IP here in Layer 7 for computing that effective policy so that we can actually come up with not just the effective policy at runtime that coalesces a lot of different components together and literally on a transaction-by-transaction basis will compute and execute that policy, but also when we advertise that policy out for external consumption, those external clients only see exactly what they have to see. So in other words, the policy that talks about how to secure a message, what kind of tokens will be accepted, maybe what kind of reliability characteristics are needed, and getting that out of the richness of policy that we offer within secure span gateways is a non-trivial task. But in fact, we've solved exactly that.
The other quick thing I'd add on to that, Scott, is just the need at policy configuration specification time to be able to test what would actually happen in production.
Yes, exactly. And that's why that whole problem of mapping policy between test environments into production environments in a very deterministic manner so you don't start to make mistakes with those things is really, really important. This was a fundamental design point in what we call our enterprise management product, which empowers you with the capabilities of actually moving that policy around. I've actually got an interesting question right here that says, in a VMware environment, vMotion server instances apparently don't automatically preserve the security policy environment. True. Well, I can't speak, specifically with too much with the characteristics of vMotion. But I will comment on a lot of the different, sort of cloud models and things like that. And Amazon might be a good example, looking at something like EC2, of how people have to think differently with instances because of the whole model of cloud, which is this idea of supporting elasticity. When you fire up an instance and that, you sort of have a base instance, and you might create 10 running instances off of those. And let's say those instances are each, writing into their local file system or something like that. As you take away, as you start to spin down, or in the Amazon world, terminate those instances, you do in fact lose what's on that, let's say your virtual local disk and that. Because remember, it is a virtual instance, and then the whole idea behind elasticity is rapid scale up or rapid scale down as well. If you want to actually take a snapshot of those instances, you can do that. But of course, then you get a proliferation of instances. We've spent a bunch of time with our own models in the cloud, and we use VMware a lot, by the way, here, and we have a VMware instance of the Secure Span Gateway. But we've also got an AMI instance that goes out into Amazon that deals with exactly these kinds of issues. And what we do is we've consolidated all of our volatile information in such a way that it can actually be very easily pulled out of the running instance and persisted somewhere else on long-term persistent storage. Or you can make use of things like persistent technologies, cloud-based technologies that are centralized, things like RDS and Amazon, that will actually allow you to create sort of instance-based parameterization, so that all of a sudden you're not as tied to, let's say, the file system and all of the volatile stuff in an instance. You sort of instead draw that out and keep that so that it can be provisioned into a different running instance later on. And it's a very effective way, we find, of being able to get the best out of cloud. In other words, the rapid scale up, rapid scale down, that whole concept of elasticity. Get the best out of cloud, but still get that long-term reliability that you really need. So with that, I think we're starting to run over a little bit.
Yeah, we are. Yes,
so Vanessa, I'll turn it back to you, and once again, thank you everybody for staying on with us. Yes,
and we should let folks know, Scott, as the questions have just been flooding in from the audience. They really stayed with us a long time today. That we do intend to answer all of your questions. We're just going to take the answers offline, and you'll receive an email back from us with a proper response to your question and opportunities to follow up with everybody as well via email. So as we are out of time, I really want to extend a very warm thank you to my great guests today, Randy Hefner and Scott Morrison. If you enjoyed today's presentation, look for future webcasts with Layer 7. Look for our email. You'll have an opportunity to review this program one more time, although we are not making the slides available. And before you go, I'd also like to encourage you to take a look at the resources area of the webcast player. You're going to find two great links there over to dig in a lot deeper and learn more about Secure Span Gateway. So with that, on behalf of Layer 7 and our publication InfoWorld, we really thank you all so much for joining us today.